So previously to this, we have graphed absolute value functions. Absolute value, if you remember about your project, were the graphs that ended up looking like this. So they are not parabolas, they're not U's. They're V's for absolute value. We can graph them, we've transformed them, but now we're going to solve their equations. So there is no graphing on a coordinate grid today. This is good old-fashioned algebra. But we're all graphing a very particular type of function. We are graphing these absolute value functions. So just to rewrite down what we talked about right before we started notes, absolute value is the distance a number is from 0. The distance a number is from 0. Because it's a distance, it's something we would measure. And since we're measuring things, like you don't put down a measuring tape or a ruler and ever measure a negative number. So we are always going to have positive answers, positive number answers when we're taking a square root of a number. So if we were to graph the two equations that you see here, absolute value, I guess they're not equations, they're expressions. Absolute value of -4 and absolute value of 4. What we're going to do is plot those numbers, -4 on the number line and 4 on the number line. Just the number that's inside the absolute value. And now all we have to do is count the distance those numbers are from 0. So how far away is the number -4 from 0? How many jumps? 4 jumps. So the absolute value of -4 is 4. How many jumps away from 0 is 4? 4. So do you see how it's a distance? It's never going to be a negative number because we're measuring how far it is from the origin or from 0. Do we see that? 4 jumps for both -4 and 4. So the value of that is 4. Now there are some properties to do with absolute value numbers, just like there's properties of like positive and negative numbers. Here they are, I almost said that backwards. Here they are in math speak, but let's translate that into words that make sense to us. So absolute value of A greater than or equal to 0 just says that it can never be negative. So absolute value can never be negative. That's what that little math sentence is telling us. Never be negative, it is a positive number. The second one to the side, absolute value of -A equal to the absolute value of A, means that distance is always positive. Because the number either being positive or negative is going to give you the same number. Negative and positive versions are the same, which we showed with the -4 and 4. The next one says that if you're multiplying two numbers but taking the absolute value of them, you can split multiplication into 2 parentheses or 2 absolute value bars. So if you're taking like the absolute value of 6 times -2, you could do absolute value of 6 times absolute value of 2, -2, and then multiply them. And the other one basically just says we can split division by the bar and take the absolute value of the numerator and the absolute value of the denominator separately, and we get the same number. These are just properties of numbers. Same that we could do these properties with like positive and negative numbers, those sorts of things. Absolute value numbers have properties. But the main idea here, so if you want to highlight something, is this right here. Distance can never be negative. So absolute value can never be negative because it's a distance. That's the main idea with absolute value properties. And now we can do some PEMDAS here, just some good old arithmetic with these numbers before we start solving the equations. So the first question here says absolute value of -4 plus 5. We should get a number. There are no x's, so there's no solving. It's just arithmetic. So question, what is the absolute value of -4? We did this earlier. 4. Okay, so this is really like taking 4 plus 5. Well, what is 4 plus 5? Don't overthink it. What's 4 plus 5? 9. So absolute value of -4 plus 5 is 9. Okay, we keep going. Let's go to the one on the side. It says 5 times the absolute value of 2 minus the absolute value of negative 3. Okay, we'll take it piece by piece. What is the absolute value of 2? 2. So this is like saying 5 times 2. And then we're going to subtract. What is the absolute value of negative 3? 3. Okay. What is 5 times 2? 10. And what is 10 minus 3? 7. So 5 times absolute value of 2 minus absolute value of negative 3 is 7. Do you see how the absolute value basically just loses the negative sign? That's basically it. It's always positive because it's a distance. To the fourth one, 6 times negative 2. What is 6 times negative 2? Or 6 times 2? 12. And then make it negative 12. Okay. What is the absolute value of negative 12? 12. So this problem is really like saying 12 minus 3. What's 12 minus 3? 9. So you see how we can just do some math basically with these absolute values, some arithmetic? We keep going. Let's do this fraction first because let's just deal with that. What is 6 divided by 3? Not minus. 6 divided by 3 is 2. So this is like saying the absolute value of negative, bless you, 2 minus the absolute value of 6, negative 6. What is the absolute value of negative 6? 6. Okay, we got a little bit more to do here because we don't have all the absolute values gone just yet. What is the absolute value of negative 2? 2. So we're just doing 2 minus 6. What is 2 minus 6? Oh, now we get negative 4. Very close. Yes, so 6 minus 2 is negative, 2 minus 6 is negative 4. So we can do arithmetic with these numbers. Yes? So that question on your homework that we would have done, you have it written on your homework paper. This was our check for understanding. It said absolute value of negative 7 minus absolute value of 7. When you do this problem, you'd think to yourself, okay, absolute value of negative 7, that's 7. And I'm going to take the absolute value of 7. That's also 7. 7 minus 7 is 0. Did you guys get 0? Yeah. So the next thing we're going to be working on is not just doing arithmetic with absolute value, but starting to solve absolute value equations. This is when you're going to have an equal sign because it's an equation. Okay, you're looking for equal signs now. There are 3 options for what this might look like. Thank you, Shannon. There are options when you're doing these kinds of problems where you have 2 solutions. And you're going to have 2 solutions to an absolute value equation when the number that it's equal to is bigger than 0. So when you have 2 solutions, that's when the number it's equal to is greater than 0. So a positive number. You're going to have no solutions when the number that it's equal to is less than 0. That means that the number is negative, if you want to put that right there. Let's go ahead and write the word positive right here. So if it's equal to a positive number, 2 solutions. If it's equal to a negative number, no solutions. And the last option is if it's equal to exactly 0, you're only going to have 1 solution. So when we are solving, there's a step where we're going to say to ourselves, how many solutions will there be? Either 2, 1, or none is the answers. But the steps that we're going to do to solve an absolute value equation are the following. The steps are labeled ISS. We can remember that. ISS stands for isolate, separate, and solve. What we are doing for those steps, isolate, separate, and solve, ISS, we're going to isolate the absolute value bars. So whatever is inside doesn't matter. As long as the absolute value bars are straight up by themselves next to some number, you have isolated it. We are then going to separate the absolute values into two equations. You're going to write, without the absolute value bars, whatever was inside the absolute value bars equal to that number, and whatever the stuff was equal to, but you're going to make it equal to the negative version of that number. That's the separate step. So you're going to have both positive numbers and negative numbers, two equations. And then you're going to solve both of those little equations so that you get x equal to two different numbers. Not the number you started with, but the number that is the solution. So we isolate the bars, isolate the absolute value bars. We separate them into positive version and negative version. No more bars. No more bars. And then we solve this and we solve that for some number. So we're going to throw it back to Algebra 1 skills where we are literally solving an equation. Inverse operations, all of that. That's what we're going to do in the separate and solve step. Okay, before you say I don't understand, let's see some examples so you can see how to use isolate, separate, and solve. We flip to the other side. We've got a bunch of examples here, so I can show you what each of them look like. The first thing we do is isolate. On this problem here, absolute value of x equal to 6, we want to make sure that the absolute value bars are by themselves, meaning there's no number in front of the absolute value bars, and there's no number behind the absolute value bars. Are these numbers, is this absolute value isolated? Is it by itself? Yes. Okay. So the isolate step of isolate, separate, and solve, we're already done with. Check. We're on the second step. That means separate. I'm going to take the equation, the stuff on the inside, and I'm going to set it equal to the positive version of whatever is right here. I'm going to also separate it into the negative version of whatever's right there. That's the separate step. You create two equations. We actually are done with the next step because there's nothing to solve. Do you see how x is by itself? That's the answer, because we want our final answers to be x equal to some number, x equal to some number. So for this problem, because it was a very simple example to start with, we are done. And so we graph the answer. To graph the answer, we're not plotting anything but numbers on a number line. So watch this. I'm going to do it. Literally just the numbers. We don't have to color any part of this number line in because it's not an inequality. We will get there. That's a lesson in a few days. But we are just solving and plotting the points on a number line. Boom, boom. We make them filled in circles because it's equal to instead of open circles. So it's important that you actually fill them in. Don't make it an open circle. Fill it in. Can I show you a little bit more of a complicated example to make all the steps a little bit more concrete before we ask questions? Okay. On the second question, are the bars isolated?
No.
On their side of the equation, are they the only thing there? Yes, obviously besides the problem number, but that's just the number of the thing. Okay. These are by themselves. So the isolate step, we are done with. If we write down ISS, we're done with the isolate step. We're on to separate. So I take all of the stuff from inside the bars, which this time is x minus 4, and I set it equal to the positive version of this number and the negative version of that number. That's the separate step. The stuff from inside the bars gets separated in a positive version and negative version. Yes? Yes? Now we go to solving. Now we have to remember how to solve equations. To get x by itself, we need to do the inverse of subtracting 4. What's the inverse of subtracting 4? Addition. So I'm going to put plus 4 underneath the 4. I'm going to put plus 4 underneath the 6. Because remember, in algebra, what you do to one side of the equation, you have to do to the other. These will cancel out. So you cross them out, pew, gone. This is going to be x equal to whatever 6 plus 4 is. What is 6 plus 4? 10. That's halfway of my solve step done. I have to solve the other one. But guess what? It's the same steps. Avion, what are we doing again? Plus 4. We're flipping it to the other side using its inverse operation. Plus 4 plus 4. The 4's cancel out. What is negative 6 plus 4? Negative 2. Negative 6 plus 4 is like 6 minus 4 would make it negative. Okay, that's the solve step. And so we graph these numbers. So on my number line this time, to show I know the answer, I would plot negative 2, and I can't reach it. I would plot 10. Let's go to the third example. In this third example, what's the first thing I asked myself? What's the first letter? Isolate. We want to make sure that the absolute value bars are isolated. Are these absolute value bars by themselves on that side of the equation? Yes, isolate step is done. I need to separate them into two equations. So we separate. We take the stuff inside the absolute value bars and we set it equal to the positive version of this number and the negative version of that number. So stuff from inside equal to positive, stuff from inside equal to negative. And then we solve. How do I get rid of negative 1? Plus 1. So I'm going to put plus 1 underneath that one and plus 1 underneath that one. These will cancel out. Oh, I'm sorry. I didn't change colors. This is definitely the end of separate. Let's go to solve. Come on, use the right color scheme, Miss Quigley. So we're solving. This is x equal to 5. There's one of my numbers. But the steps are the same. Plus 1, plus 1. What's negative 4 plus 1, though? Negative 3. Don't let arithmetic be the reason you get these wrong. If you don't know you're adding and subtracting, use that calculator. This is how it's going to be, yeah. Some of the problems are exactly as easy as this are. Now the next couple questions, I'm going to make it a little bit more difficult. So before I go, does anybody have questions about the first 3 examples? Now here's one important thing I've been skipping on purpose because I wanted us to get the pattern right. What do you notice about all of these numbers I've highlighted in blue? They're all positive. When they're all positive, you will have 2 solutions. That's what the front page said. When that number is positive, you will have 2 solutions. So if we look at this next example, we get through the isolate step. Once this is isolated, we actually need to ask ourselves, how many solutions will I have? What do we know about this negative? Is absolute value allowed to be negative? No. Immediately we stop the problem. When the absolute value bars are isolated and they're equal to a negative number, no solution. I'm done. I don't have to do any work. There's no separate and solve. Correct. I do have to make sure I've gotten through that isolate step before I do it. So once they're isolated, we ask ourselves, how many solutions will this be? The ones we've done so far have all been positive numbers, so I've skipped that step in my brain, but I need you to start doing that. Once it's isolated, how many solutions? We look at that number. If it's negative, you stop. Okay? On number 5, if we start the 5th problem, is it isolated? Yes. Okay, so isolate step is done. Now I'm adding that step where we stop and we pause. What kind of number is this right here? 0. How many solutions am I going to find if it's 0? Oh, no. 1 solution. So I don't actually have to separate at all. There's no like separating when it's 0. All I do is write it down 1 time because there's no such thing as negative 0. That's not a thing. So we don't even have to do the second one. There's no separate. And then we solve. We add 1 to both sides because that's the opposite of subtracting. This is going to be x equal to 1, and that's my only solution here. There's not 2 numbers. There's just 1 number. Do you see the difference in those 3 types of problems? When we have positive numbers, we have 2 solutions. When we have negative numbers, we have no solution. And we have 0, we just have 1. Because there's no such thing as negative 0, so you can't separate them. Yes? Maybe? Can I make it harder? Okay. On number 6, the first question I've been asking us every time is the absolute value isolated? Is it by itself on its side of the equation this time? Well, what about this? Yeah, so you're looking, if it helps you to put a big old line down the center of the equal sign like you maybe did in Algebra 1, that's probably a good call for you. You're looking on that side of the equal sign. Is the absolute value bars all the way by itself? No, so we actually have to do the isolate step. We're not done with isolate just starting off immediately. So to isolate it, I need to do the opposite of this negative 10. What's the opposite of subtracting 10? Positive, adding 10. So I'm going to add 10 to both sides. When I do that, I'm going to end up with the absolute value bar, because it's, the 10s go away, and then negative 4 plus 10, that's 6. I check again. Are the absolute value bars isolated? No. Are they the only thing on their side? Yeah. Yes. At this point, isolate is done. I think I want to separate. How many equations should I separate it to? 2, 1, or none? 2, because that's a positive number. Very good. So I'm going to separate it. 3x plus 9 equal to 6. And 3x plus 9 equal to what? Negative 6. Fabulous. That's my separate. That's my 2 equations. I mark off the S for separate. Then we solve. Now this solving takes 2 steps, not just 1, but we always start with adding or subtracting. How do I get rid of positive 9? Negative 9. So I'm going to say minus 9 on both sides. The 9s are going to cancel out. If I write down the things that I have left 3x equal to negative 3. Is the 3 all the way by itself? Sorry, the x all the way by itself? No, it's got this 3 in front of it. How do I get rid of multiplication? Division. So I'm going to divide both sides by 3 so the 3's go away. Not 3x, 3. That way x is going to be equal to whatever negative 3 divided by 3 is, which is negative 1. Whoa, pause. Let's talk about what happened because you guys are going to finish the second part of this for me. So if we have questions about the green stuff, let's ask questions about the green stuff. Okay, so when you were doing this one by yourself, you should have done the same steps because they're similar equations. Subtract 9, I would get 3x equal to negative 15. Divide by 3, I would get x equal to negative 5. What are we thinking? How do we feel? Don't forget also to plot my points up here on this number line. Negative 5, negative 1. So we just boop, boop, put the little dots there. Okay, so if I go to the next problem, like I said, I'm going to get you through the isolate step and then you're going to do the rest of it. For this problem that we see right here, number 7, probably a good idea to grab a highlighter or some sort of indicating pen and highlight the absolute value bars. Are the absolute value bars by themselves on that side of the equation? No, there's a lot of stuff going on over there. We've got this 4 in the front, and we've got this plus 2 behind it. We got to get rid of both of those things. We always start with addition and subtraction for inverse operations. So I am going to subtract 2 both sides. This is my isolate step. So I'm going to say minus 2, minus 2. Okay, the 2's cancel. This would end up being 4, absolute value of 2x plus 7, close the absolute value, equal to 16. Why did I subtract 2? Opposite of addition. And I did that to both sides. Very good. Now I've got this 4 in the front of these absolute value bars again, making them not isolated. When two things are smushed together, we just talked about this. When they're right next to each other, what is that? What operation? How do I get rid of multiplication? Division. So I'm going to divide both sides by 4. That makes the 4's go away. And I have 2x plus 7 in the absolute value bars equal to 16 divided by 4, which is 4. Honestly, if it helps you with that bar, with drawing the line, keep drawing the line down as you do this equation. Okay, now question. Are the absolute value bars isolated? Are they all the way by themselves?
No.
There's a number before or after it?
No.
We're not worried about inside it yet. We're just looking on the outside of it. Yeah, it's by itself. It's isolated. Because this number is 4, how many solutions am I going to find? 2, 1, or none? 2. I want you guys to do the rest of the steps. You have separate and solve. I want to see if we can get to the final answer here. Separate and solve. Okay, I'm going to start doing the work up on the board so you can check your work. But remember, you're doing this one, so don't look and copy it down until you've tried it. Here's what your work should look like. Yes, I gave you the fraction answers. So we would have subtracted 7 because the inverse of adding is subtracting, gotten our number, and then divided by 2 because the opposite of multiplication is division. So we get negative 3 over 2, which is the same as negative 1.5, if you got that out of your calculator. And then when you do the other one with the same steps, look, minus 7, same step. Divide by 2, same step. We get negative 11 over 2, which is negative 5.5. When we plot those points, because they're fractions, just do your best. Negative 3 over 2 is negative 1.5, so kind of put your dot in the middle of negative 2 and negative 1 for negative 1.5. And for negative 5.5, which is 11 halves, put it the best you can in between negative 6 and negative 5. So when they're fractions, I'm not going to need it to be extra super precise because I gave you a number line and whole numbers on it. Comments, questions, concerns about solving. It's the isolate, separate, solve steps. No, we okay? The third thing we're doing is writing absolute value equations. So what this is going to be, it's either going to be a word problem that you have to read or a number line, and we're going to be writing the equation backwards from the solutions. But it's really easy. Here's how we do it. We write an absolute value equation by filling in this formula. We're going to do x minus whatever the halfway point between the numbers they tell you is. That's also called the average or the mean. Do y'all remember how to do averages from like elementary school? If you're trying to find the average of two numbers, what do you do to them? Like if you have a bunch of grades and you want to know your average, what do you do with all of your grades?
Divide.
We divide eventually. What do we do first? With all of our scores. Add them up, then divide. And what do we divide by when we're doing average? So if you have two things, you're going to add them together. What do you divide by? 2. If you have 3 things and you add them together to find the average, what do you divide by? 3. That's how you take an average or a mean. Okay? The other thing that we need to know is the distance on a number line, the distance to the halfway point. Now that has a fancy mathematical word for it. If you want to know what that word is, it's called the deviation. But basically, it's just halfway, or how far it takes to get from your center point to the number that you started with, distance. So mean and deviation, or halfway point and distance to the halfway point. So here's how we do, there's like 18,000 different ways to do this. I find it easiest in these word problems to do the following. It says, in a college class, the minimum acceptable length of an essay is 350 words. We need that number, so circle it. The maximum length of an essay is 425 words. We need that number, so circle it. It wants us to write an absolute value equation that represents the minimum and maximum number of words. If this is the minimum and maximum, those are my boundaries that I want the average of. So what I'm going to do is I'm going to take the average of these two numbers. 375 plus 425. Somebody do that math for me. What is 375 plus 425? 800. 800. And then because I'm trying to find an average, I'm going to take that number 800 and I'm going to divide it by what? 2. What is 800 divided by 2? 400. My friends, 400 is our average, is our mean. That's the number that's going to go inside the absolute value bars. All we need at this point is the deviation. So I'm going to take the biggest number that I circled from the problem. What is the biggest number that I circled? 425. 425, and I'm going to subtract my mean. What is 425 minus 400? That is my deviation. That's how far 425 is from the average. So I averaged them. That's the purple. I took the deviation, which was just subtracting the biggest from the average, and now I can write my equation. We would say that the equation is absolute value of x minus the average, 400, equal to the deviation, 25. That's it. X minus 400 equal to 25. Now I want you to see, don't write this part down till I'm done explaining it, so I want you to just listen for a second. If I were to do this problem by using a number line, okay, let's say, just watch, don't write this down just yet, just watch. I have these two numbers on a number line. Right in the middle of them is the number 400. That's the average. And if I counted how much it took to get from 400 to 425, wouldn't that be 25 units? So the middle, or the halfway point, is my average, and the distance from that number to the biggest or smallest number is my deviation. So you can solve these on a number line as well. This number line would be ugly though, because it's like from 375 to 425. That's a lot of little hash marks in between them. But when the numbers are smaller, like in the example number 9, it might be easier on a number line. Let's do another one so we see another example. It says, in a cheer competition, the length of a routine is 4 minutes minimum and 5 minutes maximum. I should circle those numbers. 4 minutes, 5 minutes. That's my minimum and maximum. We want to write an absolute value equation that represents the minimum and maximum lengths. Okay, I need an average and I need a deviation. To find the average, we add those numbers. What's 4 plus 5? 9. What is 9 divided by 2 as a decimal? Well, yeah, don't let arithmetic be the thing that messes you up. Grab that calculator if you don't know it. 4.5, that's my average. That's what would be in the middle of them on a number line. All I need to know after this is to take the maximum number. What's the maximum number? 5. And I'm going to subtract my average. What is 5 minus 4.5? 0.5. I have my average and I have my deviation. So in the equation, we would write x minus the average equal to whatever we got as the deviation. And again, on a number line, this makes sense. I will show you the number line. You can write along with me this time. Here are my smallest and my biggest numbers. If I try to go into the middle of them, isn't the middle of them 4.5? That's my mean. And to go from 4.5 to 5, I had to jump or add 0.5. My mean and my deviation. My mean and my deviation. Okay, the last question also, it's really interesting because it wants us to use the idea of mean and deviation to just solve the equation by graphing. Not doing ISS steps, just looking at this right now. It is technically isolated, which is why I'm allowed to do this. But if we look at this, we know this number is my mean or my middle, and this number is the distance. Okay, so that's what I'm going to do. I'm going to make 4 the middle of my graph. And to find the solutions, I'm going to jump that distance both directions. So I'm going to go 1, 2. Here's one of my solutions. And I'm going to go 1, 2. Here's one of my solutions. So without actually solving anything here, I know that the solutions to this would be x equal to 2 and x equal to 6. Because starting at the middle and jumping the deviation or the distance both directions, I get the numbers 2 and 6. So you can, once they're isolated, solve these these equations doing the middle and the distance. Jumping 2 directions that way and 2 directions that way, whatever number it is. I feel like you have a question. What is your question? So she just asked, why do we do positive 4 if it says negative 4? You're talking about right here in the middle. The equation itself, if you look, it has an equal sign in it. So we basically ignore the equal sign and take the number.
Okay.
If it said plus right here, your number would actually be negative. So it's the opposite, basically, of this number. Instead of minus 4.5, our mean was 4.5. So it's the opposite because the negative is already in the equation.